And we are continuing to discover the topic of engineers and how to make them happy. So our next speaker will discuss a little bit more in details how to make them happier, ultimately more productive, and how to build tools and experiences for that. Please welcome Ainsley Escore-Jones.
Hey everyone, thanks for having me here. I am here today to talk a bit about how we measure and hopefully improve the productivity of developers at Stripe. Before we kick off, just brief introductions. Who am I? Why am I talking about developer productivity? I'm Ainsley, normally go by Ains. I'm the tech lead for developer infrastructure at Stripe. Developer productivity is a subset of developer infrastructure. I've been at Stripe for about 5 years. Before that, I grew up in London, which is where the accent is from, but now I live in Seattle. And if my energy is a bit lower than usual, it's because I think it's like 6 or 7 a.m. right now. So sorry about that in advance. What is Stripe? Super quickly, we do payments infrastructure for the internet. And if I'm not mistaken, if you paid for your ticket to be here, you also paid and Stripe processed your payment. So when you type your credit card number into the website, we handle that. There are about 7,000 employees at Stripe, split across 23 different countries. We handle about 500 million API requests a day or so. We have about 50 million lines of code. A lot of that is Ruby, a lot of that is Java and Go. And then our core API, which is definitely a subset of all of the services that we have, is deployed about 6,000 times a year. And so it's really, really important that we enable people to move quickly in that environment. We pride ourselves on our ability to ship really cool experiences to our customers who use our products on the internet. So I want to come and talk to you all today a bit about this transformation in my thinking and in the team at Stripe, from what I call title case developer productivity to lowercase developer productivity. And so title case developer productivity is a team. It's the team that I joined about 5 years ago at Stripe, and that team builds tools. Now, tools are part of the experience of what it's like to be an engineer at a company, but it is definitely not the whole experience. You can have the best IDE in the world, and if you have no idea what you're doing, you're not going to be a very productive engineer. Lowercase developer productivity is more talking about the concept of developer productivity, all of the things that are going into making people productive. That's not just having good tooling, although having good tooling is part of that, but it's, do people know what the right priorities are? It's, do people have enough focus time on their calendars? Do they have enough time to do deep work? Do they have too many superfluous meetings? All of this stuff and this transformation is what I'm going to try and cover in this talk. I'm going to try and contrast how we used to think about these two things separately. So to start things off, I want to talk about title case developer productivity. So this is still one of the teams that I am the tech lead of. There are about 100 engineers in total working on developer productivity tooling at Stripe, plus or minus. What do we do? Well, there's 100 people. We can do quite a lot. So we have language support. So we build IDE support, abstractions, libraries, et cetera, for all of the major languages that we use at Stripe. Realistically, that's Ruby, TypeScript, there's Java, Scala, and Go. There are other languages in use at Stripe. There's Kotlin, there is, we have iOS engineers, but predominantly these are the languages that people write at Stripe, and we need to support those as first-class citizens. Second, developer environments. We have these things called dev boxes. They are basically cloud-first developer environments. You just run a command line tool. It will spin up your developer environment, and it comes with all the batteries included to get developing on the Stripe API. All of the services are running there. All of your code is kind of stored in the cloud, and you can use Git from that box to make changes. We do CI and builds. So I want to say every time that you push a build at Stripe, if you trigger the entire test suite, I think if we ran it end-to-end on one CPU, you'd probably be waiting about 50 days. Obviously, that's a lot of compute that we have to kind of harness. And so really our job is, A, figuring out how not to spend that much compute every time someone runs git push, or that would get really expensive. But also, when you do run a bunch of tests, how do we detect which ones are flaky so that your build doesn't fail for reasons that are completely unrelated to your change? We're also heavy users of Bazel. We have a huge remote execution cluster with a bunch of really cool features. If you check out the Stripe engineering blog, it has a bunch of cool blog posts about some of the stuff that we can do with our remote execution environment. Last two things that we do from a tooling perspective, code search, code storage. We use GitHub Enterprise internally, so it's everything that people are used to from using github.com in terms of pull requests and et cetera, but we like to host it internally. We have LiveGrep, which is open source. It's our internal code search tool just to allow people to search across a couple of our really large repos really quickly. And our internal documentation is also under our developer productivity team. If you ever use stripe.com docs, we actually use the same platform internally. And so all of those like live code samples and all that kind of stuff exist in our own internal documentation, and we manage that tooling as well. So pretty large surface area that we own. And a really important question that we have to ask ourselves every day is, how is our tooling doing? How do we know that we're focusing on the right things? How do we know that these experiences are actually any good? We have a survey that we send to engineers twice a year. It's called StripeSat. It asks them a lot of questions about what it's like to work at Stripe. And inside of that, if we've detected that you've written code over the course of the last 6 months, we'll also add in some additional questions about your experience with our tooling. So for example, we'll ask you, do you think the tooling at Stripe allows you to maintain a high development velocity? And is there anything else you would like to share about your experience with developer tooling? That's a completely free-form question. You can write whatever you want in that box. And I personally read every single one of them every 6 months or so. So there are like thousands of comments that people will write. Some of them are very nice. Some of them aren't. But that's what happens when you have a comment section. What we learned from reading all of these comments is, there are a lot of engineers at Stripe, and a lot of them sometimes have really bad days. And when I first moved into the role as tech lead, we really didn't have a good way of figuring out who was having a bad day. Actually, for example, the survey is completely anonymized so that you can say mean things to us. But that also inhibits our ability to go back and be like, OK, well, where is the actual friction in our tooling, especially if people leave kind of like vague responses. And so one of the first things that I decided to do when I moved into kind of the tech lead role was really beef up our tooling around trying to understand who's having a bad day as an engineer at Stripe. So how did we go about doing that? Well, first of all, we looked at all of the complaints that people had. So people might be like, my build failed because it was flaky. I tried to request a dev box, and it told me that there were none available in my region, or something like that. And we were like, OK, which of these things do we actually quantify? At the time, the answer was like not that many of them. So when you have a group of over 100 people, it's actually not one contiguous group, right? It's split up into a bunch of smaller teams, and they all have very different opinions on what they should measure and how. And so that made it really hard for us to answer the questions, like how often do certain events happen? So I wanted to roll out a way to unify the way that we report what we call bad days. And so enter what's called Bad Day Serve. It is a service that we have internally at Stripe that's now hooked up to all of our different developer tooling. And it forwards it both to some real-time tooling. So we use Honeycomb, which is a really cool analytics tool. And then we also forward all this stuff into a data warehouse for kind of like long-term retention and trend checking. And so what you can see from this is we can see all of the different types of things that can potentially get, well, not all of the things, but some of the things that can get emitted to Bad Day Serve. So we have, did your build queue for a long time before it even started? Did your sorbet, which is our type checker for Ruby, did that crash on your dev box? Did you fail to get a dev box when you asked for one to be assigned? All of these metrics go through the exact same service with the exact same schema. It allows us to compare like for like, different types of failures that people experience. The other important part, though, of this tooling is that it also contains a bunch of metadata. It's almost like back when programs used to crash on Windows, and it would be like, do you want to send an error report? It's kind of like that, but it all happens in the background. And what that lets us do is actually see on an individual basis who is experiencing types of errors. And this is super, super powerful, because now we can actually aggregate that stuff at a team level, at an individual level. We can look at the different percentiles and see, like, are there extreme outliers here? Is there an engineer who, for some reason, like, cannot catch a break? They're constantly getting flaky tests and flaky builds. What is it that they're doing? And if they are, why don't we go and talk to them? A really fun example of this is we sometime last year or the year before that, we upgraded all the engineers to M1 MacBook laptops from the Intel ones, and people loved it. They're generally great. But it's a huge organization. Sometimes things get lost in kind of like a IT mix-ups, and not everyone got one. But what we could tell from this bad day data effectively was like who didn't get an M1 laptop, because they were like anomalously slow in some of our data, and it also had the username tied to them as well. So we actually ended up just sending them a Slack DM and being like, hey, did you get a new laptop in the mail? Have you set it up? Do you need one? Etc. And so this was a really, really powerful source of data that we could tap into to identify individuals and patterns across our tools. Now, what about slow tooling? Because originally, bad day serve was just for discrete events, like this program crashed. But sometimes things do succeed. They just succeed very slowly. And it's not clear, and at least in my perspective, that is a bad day, but it wasn't being tracked originally by the bad day serve tooling that we set up. And so we extended bad day serve to, instead of just saying, these are bad events that are happening, we said, we're going to track all of the events that are happening. And so similarly, we just kind of extended the schema to have these things called workflow events, same metadata, which user, which repository were they working in, which branch were they working in, was the time that they spent waiting a blocking set of time? So for example, generally speaking, if you hit save in your IDE, that is considered to be blocking. You can't really do much while you're waiting for your IDE to save. But potentially, something can be happening in the background. There are scripts or type checking that run in the background periodically, and we consider them to not be blocking, and so they're not kind of measured the same. This is what we use to generate a metric that we call time spent waiting on machines. And so similarly to being able to look at the distribution of bad days across the organization in terms of discrete events, we were now able to look at the time spent waiting on our tooling across different teams. Once again, a really, really fascinating insight that we could glean from this information. We could find out which teams are at the 90th percentile in terms of waiting on our tools. What are they doing? And quite often it turns out that different people have different workflows. Sometimes people will change relatively small amounts of code, push that to CI, and now they're blocked waiting on CI. And that was their default workflow. Some teams, however, had learned how to iterate much quicker locally using basal builds, for example, which would be heavily cached. Identifying those different patterns, once again, helped us focus on the right things when it came to prioritizing the work on our tools. So just a few insights that we gathered from when we rolled out time spent waiting on machines. So one of the first things we realized that the P90 time waiting on machines for a Webpack build back when we started doing this, and this is years ago, to be fair, it's not this bad anymore, but it was about 90 minutes in a day. So there were some engineers that spent an hour and a half every day cumulatively waiting for just Webpack builds while they were making front-end changes. When you see a number like that, it really forces you to reprioritize some of the things you're working on. And we did that. We actually switched from Webpack to a different bundler locally, and we got that down to people waiting 3 or 5 minutes a day. And that's just a huge difference in the life of a front-end engineer if you can change the iteration cycle from minutes for an individual change to seconds or milliseconds. And so that just jumped out at us immediately when we kind of started to roll out bad day serve. About 60% of the time that people spend waiting every day is just waiting on CI builds, and so we also realized that if we're going to make changes, that's the right place for us to be making optimizations. And now this is more recent statistics. About 1.5 million events are reported every week from all of the tools that we have around Stripe. And one of the important things to note here is that it was really important to integrate bad day serve everywhere. And that's why we have so many of these events being emitted today. And when I say everywhere, I really mean everywhere. This is every time you run a git command to do really any change in your IDE, you push a build, you load a page on GitHub. There was a time when, for various reasons, our GitHub web UI was super slow, and we wanted to be able to see that. And so really, we just rolled out these changes across all of our platforms because it was important to have visibility into all of our tools. One thing that I want to stress here is super important if you try and do this at your own company, is that you need to make it really easy for people to integrate their tooling into whatever metrics platform that you're using. If it's frictionful for people to integrate their tooling into your metric solution, they're probably not going to do it unless you really, really harass them, and you don't really want to be wasting your time having to chase people to integrate. And so for us, for example, we made it super simple. We built client libraries in every language that we use at Stripe that give you super simple wrappers around blocks of code that will emit all of the metadata for you. It will go and find it from whatever source it can accumulate it. And because we also, we're an engineering company, we have a bunch of like Bash scripts, Python scripts, et cetera. We wrote a bunch of wrappers that you could use, so you actually don't even have to modify your script at all. We actually went in and we modified and we added a wrapper around your script to gain all of that valuable kind of time-waiting information. Now, this was super valuable, but there's only so much you can learn from quantifying people's experiences with your tools, which is what we were doing. We basically started with a bunch of written complaints, and then we wanted to figure out how bad those written complaints were, and so we went around and we started like wrapping all this tooling in a bunch of instrumentation so that we could see what was happening across our engineering population. The problem is this doesn't really tell us about the interactions between tooling, right? So say I have a build that I push to CI, and it tells me, hey, your build failed because you formatted this file wrong. It might even suggest an auto fix for me that I can then copy and paste back into my IDE. That's fine, but that's still kind of an annoying experience to have. I would much rather have gotten that information before, ideally, an entire CI build had run. Similarly, if a piece of documentation is out of date, or if a tool produces something in like a slightly incorrect format so that when I put it somewhere else, it doesn't work, we don't see any of that information in bad data. We don't see those experiences. We just see, oh, this person spent 5 seconds over here. So we then moved on to this project that we called Papercuts, also known as the sad octopus button, which you can see in various places in some screenshots here. So CI-bot is our CI interface that you use to look at your builds. It was also possible to report Papercuts from Slack by using this emoji, and pretty much in any website that we owned inside of Stripe's internal network. And so what's a Papercut? It's basically just a super low-friction way of reporting friction in your developer workflow. And so as I said, anywhere that you saw this button, you could press it and then just super quickly write a super quick vent note to us. It came to a centralized team that owned processing and triaging all of these complaints. And also, whenever we had the time, we might fix them. So if someone just says, hey, there's a typo in this documentation, we might just go in and fix it. If someone says, hey, this tooling's a little bit slower than usual, we might profile it and see if it's an easy fix or a hard fix. Now, the important thing to note here is that we treated this like an internal product launch, because we really, really wanted people to use it. And so when I say, the thing about the sad octopus button, the whole plan was so that people associated seeing that icon with the ability to get an actionable complaint to us. And so there's two things there. One, it's rolling out everywhere, and two, it's actually changing stuff as a result of this. Because one of the things we really wanted to avoid is making things worse for engineers, in the sense that it probably feels a bit worse if you push a button, report something, and then absolutely nothing happens. Eventually, you're just going to stop reporting stuff. And so it was really, really important to us to at least acknowledge that the tickets came in, fix them when we can, and keep things going. Now, over the course of about a year of the first iteration of the Papercuts program, people submitted about 1,500 of them by 500 different engineers, and we got around to fixing around 100 of those Papercuts. And I want to talk a little bit about the lessons we learned from that experiment, which was, it was really, really good from a sentiment perspective. I think for the first time in quite some time in engineering at Stripe, people felt like they were being listened to. They felt that they could report an issue and that someone would come in and acknowledge it and potentially forward it to the right team. We solved a lot of ownership issues for people as well, because we really rolled this out everywhere, but we didn't force people to go and figure out who actually owned the tool. We would do that for you. Having that single source of intake was a superpower for us, because it let us look at kind of things more holistically across the entire company. And by that, I mean we could start to spot patterns and trends about the types of things that were annoying people. And if things got to a certain critical mass, at least once, we just like opened an incident, an internal incident to say, like, this thing is sufficiently frictionful and bad that your team should really prioritize fixing it because, in some sense, you can convert lost engineering time into, lost expenses for the company. Paper cuts are sticky. That means that because we actually did show people that we responded to this and made changes, people kept reporting. The people who were engaged with paper cuts were super engaged over long periods of time. However, the intake and triage process is not scalable in any way. Actually, the more people get interested in reporting paper cuts, the more you kind of start drowning under this deluge of complaints that people have. And this leads into saying that they're not always clearly actionable. People have definitely just written a paper cut to say, like, builds suck, which potentially is true. And the other thing is eventually you'll run out of low-hanging fruit. We actually spent a lot of time picking off low-hanging fruit. We would go and fix a flaky test here. We would go and integrate tooling slightly better there. But eventually you do start to get real deep issues at the core of your tooling. So for example, actually someone might tell you that a piece of tooling is slow, but fundamentally, perhaps that piece of tooling is doing static analysis over the entire code base. And if your code base is tens of millions of lines of code, there's only so fast that you can do that static analysis without some kind of deep overhaul of that piece of software. And at that point, you really now have to think about, like, how do we turn this from a queue of things that we can go ahead and quickly fix into kind of a pipeline of projects that we're going to have to do over the longer term. So we kind of took all of these lessons from paper cuts and we evolved it into kind of the next generation of paper cuts, which is something that we're doing this year. The sad octopus is still there. We still want to keep people's muscle memory from reporting them. But instead of keeping the triage process to be manual, we're actually trying something a little bit different now, where we're actually allowing people to vote on paper cuts as they come in. And then we prioritize the things that people around the company deem to be the most important paper cuts to work on. And so the idea is here is that we're kind of like crowdsourcing a bit of that importance and triaging understanding of these paper cuts and issues because it's super expensive to handle potentially hundreds of tickets a day or something like that. And so we want people to go around and tell people, like, is this annoying to you too? And hopefully self-sort. Now, we're super early days on this, so we'll figure out exactly how that works, but it's kind of a strategy to keep what we think is a super powerful mechanism to understand how our users are feeling and make it more sustainable. Don't know why that cut off, but last thing I want to talk about is what we do in terms of shadowing our engineers. And so this is the last part I want to talk about how we understand how people think about our tooling, which is, honestly, sometimes we just watch them code. And so, pretty much how it works is we'll find engineers around the office and we'll be like, hey, do you mind if I sit with you for an hour and just see you work on whatever task you're working on, get a little bit of context from them about what they're trying to do, and then just kind of sit back and observe. Now, understandably, sometimes that can make people uncomfortable. And often what I say is, honestly, if you're like struggling with a piece of tooling, it's more of an indication that I'm doing my job poorly than it is that you're doing your job poorly. And so, like, feel free to use me as a resource. Like, I'm here. I probably built some of these tools, so you can totally leverage me if you get blocked on something. But also, don't feel embarrassed. Like, as I said, it's a failing of our team if you can't use this piece of tooling. And so, shadowing, super low volume. There's only so much time that you can spend shadowing people, but really, really high bandwidth in terms of the information that you can get from how people are using your tooling in the real world. All right, that's enough about tooling. I want to talk a bit about lowercase developer productivity. So back to StripeSat. We asked people other questions on StripeSat too, not about tooling. We asked them overall, in the last month, how productive have you felt working at Stripe? And is there anything else you would like to share on developer productivity? And once again, here, we're not talking about tooling. We just ask people, like, what is making you unproductive? Let us know. And what we learned was all of the responses started to fall into a bunch of different categories that were not necessarily aligned with our tooling. And we came across this paper from Microsoft and GitHub research, which was called Space, which gave us a really useful framework to start to think about how to categorize and understand some of the other problems that people were talking about. And so what does Space kind of stand for, and what does it mean at Stripe? So the S is satisfaction. How do people feel? P is performance and outcomes. We'll talk about that, but generally it's how well is the company doing as an output. Activity are just measures of things that people are doing. So that might be like merging pull requests, where are people spending their time? They might be doing interviews, which is still useful for the company. It's just not necessarily producing code in your repository. Collaboration and communication, which is to say, like, how much interaction are there between different teams? How much time do people spend blocked on other humans? And efficiency and flow, which is how much focus time do people have? Back to the original measure, how much time do people spend waiting on tools? We kind of assume that is them being blocked, that is their time being wasted. So this kind of like fans out, and these are a bunch of the metrics that we decided to measure as a result of looking into the space framework. Now, when it came to implementing space actually at Stripe, we actually cut out 2 parts of it, at least from my team's perspective. So the bits that we didn't worry about were performance and outcomes, because those are super, super far away from us, right? Like, how much money Stripe processes in a given year is quite detached from any single developer or even our team's efficacy. And secondly, we didn't really focus on activity metrics. Activity metrics are kind of your canonical output metrics. How many lines of code do people produce? How many pull requests do people produce? These are interesting metrics to look at in aggregate. I mean, generally, if the number's going down, you can assume that people are writing less code and doing less productive work. But it doesn't really tell you what to do as a result of that number changing. And so we don't spend too much time focusing on it. Instead, we looked at satisfaction, efficiency and flow, and collab and communication. And so we decided, OK, what are the actions that we want to do as a result of adopting the space framework internally at Stripe? And we said, well, we know the positive effect that fixing these paper cuts and reducing the bad days has on people's satisfaction. Efficiency and flow was interesting because we really hadn't focused on this up until this point. But what we saw from the StripeSat comments is people were like, I don't have time to actually write code. I'm in and out of meetings constantly throughout the day. And so we wanted to emphasize focus time. How much contiguous time do people have to do good engineering work? And then finally, collabs and communication were also a new theme of problem that we saw when we started looking outside of our tooling. We wanted to drive down how often people were blocked on other humans. And you can be blocked on people for many reasons. Simple one, code review. More complicated ones are perhaps there is a process where we're a payments company, we're a money-moving company, where you do need 2 people to authorize a certain change. That is necessary from a business perspective, but what are the things that we can do to reduce how often that happens and improve how quickly you can get unblocked? So we used Space, once again, for about a year. We used it pretty much all of last year. And a couple things to note are, number one, deciding which metrics to use is super tough. So Space gives you a framework, but it doesn't actually necessarily prescribe which metrics you should be using in each of the categories. There is a lot more art than science when it comes to deciding on which metrics to use. And secondly, maintaining clean data for all of the metrics, super expensive. The more metrics you do, the more pipelines you have to build, the more interesting conversations you have to get into with your coworkers about whether or not you should be measuring the P50 or the P90. Does this outlier matter? Is this team really software engineering or not? That is a super deep conversation to get into. So for example, at Stripe, we have engineers that work with our customers to help them integrate into the Stripe API. Should they be considered the same as an engineer that works on security internally at Stripe, as someone who works in IT, someone who works in the API? These are all questions that we went back and forth of a lot when figuring out what should go into our space metrics. And that was super, super expensive for us to do and constantly tweak and iterate on that model. And so we decided to instead land on a simpler model for how we wanted to use kind of a space-like framework internally at Stripe. And here's what we settled on. Just these 3 kind of pillars that we focus on right now. So sentiment is still there. There's a really interesting paper, and I'll have some links to some papers at the end of this talk, that talks about how important how people feel about their productivity is when it comes to measuring their productivity. It's super highly correlated with any objective measure of productivity that you can really find. But it's also important for a bunch of other reasons, right? You want to retain your engineers. You want them to want to keep working at your company. And honestly, asking them how they feel is a pretty good predictor of how much longer they're going to stick around. Second, focus time. How much deep focus time do people have? Now, this metric I'll talk about in one more slide, but I really want to stress that this actually is not necessarily about how many meetings people have or how many hours that they spend in meetings. This is actually more about the fragmentation of their meeting time. If people have 2 hour or 3 hours of meetings in total across a day, but it's spread out a bunch of half-an-hour blocks throughout the day, they have very little time to actually deeply focus on solving any one problem. Instead, if they have 3 hours of meetings in the morning and then the entire afternoon free to do good work, people feel a lot better and can do a lot better work. Last one here, branch to master time. So this is just measuring the total end-to-end time from when you create a new branch on your laptop to when you land a PR. OK, so here are some quick things that we focus on. Improving sentiment, as I said, we keep up the focus on paper cuts. We give teams time to reduce KTLO and tech debt. And we proactively communicate our improvements about developer productivity to them. There's a super kind of recency bias when we ask people how they feel about developer productivity. And partially it's because people can forget quite quickly when things improve. There's kind of a reversion to the mean in terms of how people feel. And so we like to keep people up to date, not only because it makes them feel better, but also because it's actually quite likely that the longer that someone has been at the company, the more they potentially adopted some bad habits or certain workarounds that we can tell them that we fixed, and people get quite entrenched in their ways. Second, improving focus time. So this is a screenshot of one of the tools that we now give to engineers and managers that lets them see how much focus time they have on their team. And the way in which we define that is that we say we want people to have a contiguous block of at least 3 hours of focus time every day. And if you get the majority of the days of the week with that sufficient focus time, then that's considered to be good and great, and we kind of like track how many people have that on average. Once again, this metric is mostly optimized by people packing their meetings together and deleting meetings, and it's less so about, once again, the sum aggregate time of meetings. And so we gave people this tool, and we also asked people to coordinate meeting blocks across the organization, which is to say, if multiple teams need to meet with each other, it's much easier if they all agree on, say, 9 a.m. to 12 p.m. Pacific than it is for them to all have slightly different meeting blocks, because once again, you get that fragmentation problem. Last thing is improving branch to master time. And so one, code review turnaround times are really important here. One thing we realized is the vast majority of time spent going from branch to master is just waiting on code review from another person. And we actually measure that in 2 parts. There's the time it takes someone to open your pull request at all, and then second is the time it takes them to actually review it once they've opened the page. And once again, a pull request for a really simple PR can honestly take seconds in which you can unblock your coworker, but people could take hours before they look at your PR. And we found that that imbalance was super, super rough. And so we came up with ways to kind of nudge people to do the right thing depending on the size of the PR. And we really, really focused on driving down how much time people spent blocked on code review. Second was streamlining what we call golden workflows, which are commonly trodden paths in our engineering workflows that we want to basically make fit together seamlessly. So we, through that shadowing process, found out what people were doing, and then we said, OK, if you're just adding a new button to stripe.com and hooking it up to an API, how can we make that workflow as efficient as possible? Like, how can we do code generation? How can we make it so that if this is a minor change, you maybe don't even have to wait for code review? Streamlining all of those steps into what we call golden workflows means that for the vast majority of pull requests, people can get them done much faster than they could before. All right, key takeaways as I'm wrapping up. So, title case developer productivity, speaking about tools. Tools are important. Ensure that you're measuring everything that you're hearing your users complain about, and make it really easy for your users to complain. Also importantly, if you make it easy for people to complain, please don't ignore them. They'll get turned off from complaining super quickly. Don't just rely on your metrics, though. Shadow your users while you work. One reason I say shadowing is important is I know sometimes we think we're engineers, they're engineers, we work the same. At least in a company like Stripe, it is meaningfully different to be working on the API than it is to be working on internal tools for a bunch of reasons. And so it's important for us to see how people are actually working in their own projects. And then with lowercase developer productivity, it's important to say that tooling is not everything. Dora and Space, which I'll link to on the next slide, are great frameworks as starting points, but feel free to customize them for your own organization. And you can't fix everything at once. You'll identify a lot of problems when you start paying attention to the things that are not tooling, but it's important to just pick the highest leverage areas that you can focus on and work on those. And so this slide, I just want to give some credits and shout-outs where it's due. So Rebecca Murphy is a former colleague of mine who really helped develop our sense of engineering success, engineering velocity at Stripe, and introduced us to the Space framework. She's still working on developer productivity at a different org, but she has a Substack, which is great, some great thoughts on developer productivity. GitHub for the Space paper, also linked to that QR code. Facebook for what they called code gestation time, which inspired our branch to master time. And then Google Research have some really fantastic papers, one of which is called What Predicts Software Developers' Productivity, which you can definitely give a read. It shows a bunch of measurements that Google themselves use in order to measure, understand, and correlate with ultimate success of engineers in their organization. And so that QR code just links to a bunch of other stuff. All right, that's me. Yeah, we are hiring at Stripe on developer productivity if anyone is interested, but thank you all for your time.
Awesome talk. Thank you so much. Maybe Stripe should have the booth next year. It's going to be easier to hire people. All right. We have a lot of questions, and we have not so much time because straight after this, at the main stage, there will be the announcement of the winners of the raffle and also Craft Hack winners announcement. But we will go for several questions, right? Right. Do you get pushback from engineers when they understand how much data you are collecting?
Yeah, I'll try and speed run through as many questions as I can. Yes is the answer to that question. People were originally concerned with this. When we talked to them, though, I think it's primarily that they were concerned that this would be used to target individual engineers. That is to say, it's performance review time, your manager's going to look up, like, how much time did you spend in your IDE? We, A, communicate that that is useless information and that managers should not use that. But two, we tightly control access to that data. We normally only share it in aggregate, so we'll aggregate at the team or organization level before we share that out to people. But it's really a balance between, if you anonymize data too much and aggregate it too much, you really are flying blind when it comes to knowing if you're working on the right things. But then obviously the privacy concerns or the perverse incentive concerns if the data gets out too widely. So that's kind of the balance.
All right, thank you. Next one. What tools do you use to measure focus time and branch to master?
What tools do we use? They are all our own internal data pipelines. There are some not open source, but like commercial products that you can use. I believe one is called Swarmia, and the other one is called OKHQ. So one thing to note about Stripe, as I said, because we're kind of like a highly regulated payments company, the thought of just like accepting some random company and they're like, can we have access to all of your engineers' data and laptops and calendars is kind of scary for us. And so a lot of this stuff is built using our own data processing tooling internally. But as I said, there are some commercial things. If you have like a slightly different risk profile that you can just go and get off the shelf, hook them up to your Google Apps account, and they will do a lot of this analysis for you.
Thank you. Can you share more about your calendar fragmentation measuring tools, please? I believe
similar.
We just answered that. Love your energy work on presentation.
Thank you.
Thank you, guys. Maybe the last one. Are the dev prod metrics used for evaluation, compensation, or even layoffs?
Nope, absolutely not. That's pretty much it.
That was quick. OK, let's take the next one. Is it possible to do and then measure these on a monolith projects, for example, 400 developers working on it? If yes, how?
Yes, the Stripe API, generally speaking, is a gigantic monolith where way more than 400 people work on it at the same time. And so we have a lot of experience with working and measuring people's productivity in a huge monolith. I don't want to get too much into the holy war of monoliths and microservices, but needless to say, if you invest in tooling, assuming that you're going to have a monolith. So for example, at least for the most part, Facebook is also a huge monolith. You can build tooling that theoretically you can get a lot of the benefits of having a monolith. So you can make atomic changes, for example. But if you invest properly in your tooling, you can get kind of like incremental builds, incremental type checking, et cetera, so that you don't have to analyze the entire thing all the time, only the thing that you're actually working on.
All right, thank you so much. Let's wrap it up. Let's give a warm hand to Ains. Thank you so much. Woohoo!